Okay, here's the question. Suppose we're trying to use Newton's method to get an approximation for the roots to this equation. We would like to know, why is x1 equals 1 a bad initial approximation? What do you guys think? Well, here's the deal. First off, we want the equation to be 0. This is equal to 0. Perfect. So we can just say this right here is our function. So I'm just going to code that to be f of x, which is just x to the third power minus 3x plus 6. And let's recall the Newton's method. Newton's method says we have to have xn equals xn minus 1 minus the value of the function at that previous x value divided by the derivative over there. Aha! You see that we have an expression involving fractions, and we have this denominator here. In fact, this is the tricky part. Yeah. In this case, we just first have to make sure that this right here, we have to make sure it's not equal to 0. So that's the whole thing. So if we just differentiate this real quick, we see that f prime of x is just equal to 3x squared minus 3. And if we want to use x1 is equal to 1, okay, we see the derivative over there is going to be 3 times 1 squared minus 3, and work that out, we will end up with 0. Imagine if we put 0 on the bottom here. Of course, it's no good. This 0 in Newton's method is a bad number, alright? So the idea is that we cannot have the derivative being equal to 0 when we are trying to use Newton's method. And because we'll get a horizontal tangent line, there's no way for us to actually get this going. Well, if you can look at the formula, we just don't want to have 0 on the bottom. We cannot. So why is this a bad initial approximation? Well, I'll just tell you that because f prime of 1 is equal to 0. Perhaps this is the shortest way to answer this question. And that's it.